Good morning, all of you. Good morning, everyone. Good morning, Kranti sir.
Yeah, good morning.
Good morning, sir.
Give me 1 second. Let me just switch on
Yeah,
my
sure.
video. Give me one
We
second.
will start the session in a while, sir.
Okay.
Good morning, all of you. आवाज नहीं है वीडियो ऑन करके देखिए Good morning. Good morning to one and all, and a warm welcome to the fifth day and the final day of our faculty development program. It has been a wonderful journey so far. Let's dive in with the same enthusiasm and curiosity that has brought us this so far. Let's welcome our speaker of the session, Mr. Kranti Dharani Kota, sir. He is currently working as a senior solution architect in US. He has extensive experience as a solution architect and staff engineer, marked by innovation and successful project execution. He is proficient in designing, implementing, and optimizing large-scale distributed systems and streaming applications using AWS cloud computing. He has vast experience in machine learning with a focus on leveraging advanced techniques. I would request Mr. Krant to begin the session and share his valuable insights. Sir?
Yeah, thanks for that, Shilpa. You can hear me? Can you hear me? Yes,
Yes,
no?
sir.
Okay,
Yes,
perfect.
sir. You are audible.
Okay. I might have trouble with sharing my screen a little bit, but I think I'll just start sharing the screen. I think we can probably begin, unless you want to wait for a couple more minutes. Are we good to start right now?
Yes, sir. You can start now. You can share your screen.
Okay, give me 1 second. All right, give me 1 second. I think I have to probably switch to a. Okay, so you could confirm what you could actually see, and then we can probably begin.
Yes, sir. I am seeing this collaborate screen, the code.
Okay, you should probably see a presentation like a machine
Yes,
learning
now
page.
the presentation is visible.
Okay, perfect. That makes sense. All right, give me 1 second. All right, I think that's good then. So I think thanks for everyone for adjusting to the time. I think it's probably a little early for you, maybe like 30 minutes early based on what I would able to know. But I think given a time that we have, like within an hour, maybe let's see what we can probably, cover in terms of the machine learning. So I'm probably going to talk about some of the stuff, and then maybe we could look at some of the practical implementation of the machine learning with an example what I have. And I think maybe let's jump onto that. And I think if you have any questions, you could probably put in the chat. Maybe we could do it right in the session, or maybe we could do it towards the end, whichever way that is convenient. And I think if you do have a question, you can turn on the video, and then you can also probably, just ask the question. That's fine. We can get to see how we can probably do it. And I think I might have little trouble on the chat window because I'm not much familiar on the Zoom, but let me see. Okay, I think I could able to see the chat window right here. And let me move this. Let me make some couple of adjustments before we begin. All right, I think I'm good in terms of the banner and all that. And I think if you're good, I think we can get going. Shilpa, I think you would be coordinating this if I have any question or something, or maybe if the audience has any questions.
Yes, sir. Yes, sir.
Okay, perfect.
Yes, sir. Participant can ask the question. If anybody can write on the chat box, I'll let you know.
Okay, perfect. That makes sense. And thank you. All right. I think Shilpa already gave a background of, but I think just to get a context set, I think, yeah. So I'm a solution architect working in a financial company, and I wanted to share some of the insights of machine learning and AI. And I think with an extent of in the today's world, right, we got a lot of LLMs, like the large language models. We got a lot of boom on the AI, and I think maybe we could cover some of the concepts was the intent. So my area of expertise is primarily on real-time distributed systems, more on the streaming side of applications, maybe not like a Netflix streaming, but like more of a streaming real time, in terms of like, think of like a machine, think of like a car, right? On the moving, and then it's sending a lot of different data, and then you got a cloud systems that can able to manage all of the different data, right? So I work on some of those real-time streaming applications, and I think primarily it's on Java, Scala, and then Python, and some of the stuff that I've been doing recently was also machine learning. It's a vast subject, but I think we can see what we could do. So I think I'm just learning some of the machine learning stuff and the prompt engineering. It's based off the some of the chat GPT engines what you have seen. So I think those are some of the things. But I think that's about me. So let's dive into my missing probably a title here, like which says like how much of amount of data that we are actually sending today, right? So think of like um, we got mobile phones, we got different sensors, we got different Wi-Fi devices, and we got a lot of devices out there, right? So the amount of data that's being sent today, per minute maybe, that's a lot of data. So can you think of maybe like if you have to quantify the amount of data that's being sent out, I would like to see if somebody could able to guess the amount of data that we are generating today, in terms of what's the volume look like, maybe like a day or a month. Can you know like some kind of a metric from the audience? Yeah, so I see petabytes maybe per day. Yeah, and I think you are definitely close, but I think it's the power of petabytes of data what we got today. So I think my keyboard is not working. Give me one second. Let me just go to the next slide. Okay, so the data that we are having today is zettabytes, and I think while I was looking at some of the data metrics today in the entire world, I think we see a kind of a zettabytes of data. So that's a lot of data. So if you're wanted to know like how much of this in terms of uh, the petabytes, I don't know the numeric conversion, but I think this is an average human device, right? You're capable of generating like every device generating of few megs per data, few megs of data per second. So multiplied by that number, you got 147 zettabytes. They call it as. So which is like 1 trillion GB. And I think this is just want to give an understanding on how much of data that we are actually dealing with today. So as we talk about the data, right? So I think of different things of the data, right? So one of that is that there are different things, of course, in terms of the data. We talk about data science, big data, AI, and then also machine learning, right? Um, so these are different type of data definitions, and I think most of them are probably aware, like the amount of volume of data. What I wanted to mention is huge. What we are having with the AI and the ML stuff that's been around, we are talking definitely a significant amount of data. And then with the amount of data that we have, you need to probably think about like how can we make use of the data in real time, and then how can create data insights out of the meaningful data what we have, and then maybe how we can probably make use of the data for the business insights. If you're out to probably look at data, right? Everybody is playing around data is the king. So if you got a data, so then I think you need to probably have a meaningful data on how you can probably derive data insights from that. Of course, we're not talking about some of the data science stuff, but we're going to look at some of the data visualization on how that can be possible. And I think that would be one of those keys for the data. But anyway, moving on to the next thing. So what I got here is a data pipeline. Okay. Um, so maybe like, I have a question, and then, I want to get an answer for my question. And the question can be anything. It can be a business question, or maybe it could be an engineering question, or maybe it could be anything, right? So as we talk about the data, I see the data as a pipeline where, you wrangle the data, you clean up the data, right? Required. I mean, you basically clean up like some kind of unwanted data. You basically remove that, and then you explore kind of an exploratory way, discover the data. And of course, you do the pre-process of that exploratory process, and then you model the data, right? And then you use some algorithms, to model the data, which we can talk their different modeling techniques again. And then end of the day, you validate the data, and then you tell the story. You know what? Yeah, we got this data, and this is how the data can be used for the business. Whatever the business applications that you're working on, whether it could be like, maybe like a telecom, maybe a financial, maybe it could be a banking, maybe it could be medical records, anything of that. So I think there's a lot of process involved as part of this data. So just to give a explanation on how that, that the pipeline, that end-to-end flow looks like. So I think moving further down, yeah, so I think this is one of those things, as we basically look at different business scenarios, the machine learning, and I think I'm not going to go into the different concepts of the machine learning, just that, you had some kind of sessions in the beginning of this week, right, on some of the machine learning. So I expect, I don't expect like, pretty much everything, but, we understanding that, you have some kind of understanding on what a machine learning is. So the machine learning is basically, it talks about different use cases. So let's say you got a question, right? And let's pick up, maybe let's say the fraudulent transactions. So you got a credit card, right? And you're making use of your card, and you're swiping transactions, you're making transactions, in terms of, the shopping that you are doing, whether it's an online or in store, whatever the experience that you are doing it, right? So how can we, trigger a kind of a pattern where you could identify a fraudulent transaction, like looking into the amount of transactions that a customer is making. So I think you would need some kind of an algorithm, right? And this is not pretty new. This has been there for a while, not just before even the machine learning, maybe. But I think the machine learning algorithms have become so robust right now, right? You could make it things little better than what you have right earlier, and like maybe a decade ago. So think of the same things, like you got some of the customers, right? And then I think you got some of the customers, let's say you got a telecom company, maybe let's say Airtel or maybe a AT&T network. And then, the customers are switching from one telecom provider to another telecom provider, right? So you wanted to know, like how exactly, how many customers that you're actually lost maybe within a month, right? So you want to derive those metrics, and then based off that, you wanted to make some necessary corrections within the business. So I think those are some of the anomalies that you can probably detect. And the most important thing, yeah, I think we always look at the email classifications, whether to identify the spam, or maybe, to classify what kind of email it is, right? It's a genuine email, like it's a legitimate email, or maybe it's a fraudulent email. So those kind of classifications. And then the last but not the least is the predicting house prices, right? You have a real estate market, right? You got various housing prices, and then you wanted to know, how would your house value would go up, or maybe it would go down, depending upon various parameters that you look at in the data. So for all of these things, you would definitely need machine learning algorithms to determine this. And I think we will probably look at one of those examples. Um, so as you look at also the data, right? And I think this would be something interesting to look at, what kind of data that you are dealing with. So I would put these data into three buckets. One is structured and unstructured, and I think one which is in between, which is the semi-structured data. The structured data, as we all know, it's typically coming in from, a couple of spreadsheets, databases. And then you got the structured data, right? And which has a schema and all that. The unstructured data is going to be tricky. You got data in terms of, the audio files, you got a data in video files, and a couple of documents, which could be like a PDF file, or maybe it could be any kind of a format, maybe a Word document, or it could be anything. The semi-structured, though, it is something like you got a mix of that, right? Where, the example of a semi-structured could be an email, where, the email can probably contain a body, maybe a text, right? And somebody can send me an email with an audio file, or maybe they can also send me a video file, right? So that's a kind of a semi-structured format. And I think this is just example of, various data sources for the different category of sources of data, what we have been generating out, and how we are trying to represent the form of a data. Um, so I think that's about, the data sources. And I think as we go into the details of this, um, we talk about the data wrangling, right? So assume like you have a data now, right? Like we talked about, the data might not be meaningful. It might not be in a way that you cannot able to consume in a fashion directly. What you actually would deal with it, excuse me, what you actually deal with the data is you would actually analyze what kind of data you have, right? So something like, let's pick up, like you got some kind of a demographic information, collecting some kind of a survey responses, right? Maybe it could be an election survey response, or maybe it could be a demographic information contain the let's say a person's age and maybe their sexuality, and then the place where they're living in, what kind of annual income that they're making, things like that. So for such kind of data, right, you would get a data, right? But you would not many times that you might have all the data for let's say I pick up like 100,000 people, right, in a geographical area. And if you're looking at the data for 100,000 people, maybe like just say like 1 lakh people, right? Um, you don't expect the data to be pretty clean. So the intent behind this is, a lot of these machine learning engineers or maybe the data scientists, they spend most of their time in basically cleaning up the data, like the pre-processing of the data. And that's where they spend most of their time. Because I think if they're not going to spend time on that data cleanup process, essentially when you create a machine learning model, your model output might not be so accurate, right? It wouldn't be so accurate that you can able to predict the outcome. So those are some of the things that you would have to probably take into consideration when you look at the data. And these are some of those things, like, how we can probably uh, do couple of ways to, transform that data, what you got. So as the data gets ingested, right, and through various sources which we have seen, some of the techniques that we would probably look at in machine learning is, you basically interpolate values. That means you basically substitute, you input some of the values. That's one thing. And then one other technique is, let's say you got some kind of a categorical values. Excuse me, categorical values is something like, there could be some columns within the data. Let's say when I'm talking about data, let's assume that you got a data in a spreadsheet. Okay. And then you let's say you got a spreadsheet of data, and then let's say one of the columns has maybe it's not numeric, but you got some kind of a character based column, which you think that it might not be necessary for your project, for your prediction of the ML model. So what you do is you try to convert some kind of a Boolean logic in it, and then you convert that meaningful values within yes or no, like maybe like ones and zeros. So that would be one technique how you could actually do the convert that data, and we call this as a categorical data, or maybe it's an object data type in Python. I think those are some of the things, and then you basically discard, which is another thing here. You discard some of the data which is not required, and you basically substitute some of the data with not applicable, like nan, like you substitute with a null or something. So that way trying to avoid meaningful, not a data which is not meaningful. Deduplication, yeah, you try to avoid any of the duplication in the logic. So these are some of the techniques. So we're seeing the missing values, and removing duplicate categorical values. These are some of the things that we will look at in the example. So data exploration, which we just talked about, like I was saying, like, if I'm an ML engineer, right, and I have a different problem to solve, right? The data might not be meaningful right away. So I would have to probably spend some time on doing an exploratory data analysis, which is called as an EDA. Now, doing an EDA, which is an exploratory data analysis, there are some tools how you could do that. You could do the exploratory data analysis on maybe on particular fields, and maybe you would have to probably sometime group few columns, right? You would have to probably do some kind of a linear regression model, like where you try to compare, as as x increases, the value of y decreases. So some kind of a linear algebra formulas are involved. So for that, you would have to do some kind of an initial investigation, and you do some EDA process in that. And there's some libraries how you could actually do that. So I think, so those are some of the data exploration concept and how it is being done. And on the right, you have some kind of a bar plot or a histogram, and then you got different heat map that you can actually generate out of the data. And then you try to compare, visualize it and how it actually looks like, whether the data is making meaningful or not, is some of those techniques that we would look at. But I think the concept here is EDA, to remember. This is a pretty backbone of all the exploratory data analysis that every machine learning engineer would have to go through. So I think that is one of the things. I would probably stop here and then see if anybody has any questions so far. Okay, so then I probably take it as no, then we'll keep continuing. Okay, so model building. Okay, so I got another slide. I think I got maybe a couple of slides, and then we'll go into the Google Colab, which is part of the demo. So I think of like, so what's next, right? So we done the EDA, right? We basically looked at the data. You made some analysis on the data, how your data should look like, right? And what kind of parameters that you want to evaluate the data. So after you do that, you get into the process of, the model building. And I think the model building talks about different techniques, right? And we would look at the category of different techniques like the supervised, unsupervised. And then you also talk about the deep neural networks, which is not part of the discussion what we are trying to do. But I think you get into the model aspect of it, and how probably start building the model based off the ED analysis. So this is just like, um, a kind of like an image that says, they got two of the friends here, and then they're trying to, um, put up a pile of data, right? They wanted to have a data, they have a data, excuse me, and then they want to go through the machine learning system as part of the data that they have. And these two friends are chatting. They are saying, hey, you know what? I need a prediction of my data, how that looks like. And this person here in the image is saying, you know what? Just dump your data in this hole here, all the data. You dump all the data, and then you collect the results on the other side of the pile of what you got here, as an example. So once when you come back and then look at the results, right? Once when you dump the data and then look at the results here, the results might not be as predictable as that you actually expected, right? So then what you actually do is basically you do the same thing over and over again, right? Because you don't expect the right results based off the data that you have. And sometimes the model that you actually build might overfit. There are two concepts. One is the overfitting and underfitting of the data, right? Overfitting is like, there are some kind of an outliers, like, there's not something, there's more noise in the data. So all of this is tied with the data and with the noise. So when you have more noise in the data, like more of errors, which outside the boundary of the analysis, what you want to explore. So that's where you call as errors, or maybe you call as overfit. That means your model is not fitting to the right context of the data. Underfit is something like, your model is not performing to the expectations, which is an underfit. So I think, and I think we would probably look at, might not be looking at much of the model fine tuning parameters, but I think there is a fine tuning concept again, which is they call as a hyper tuning of the model, which is kind of an expensive in terms of the modern day compute. But I think you would have to probably do look at some of those hyper tuning parameters at a later stage when you get into the more advanced level of machine learning. But I think the concept is only one if I have to summarize this in a one short line, right? So I would probably say, you would have to tweak your algorithm, and you would have to train the model continuously, examine the results and over again, such a way, you have that accuracy of maybe, let's say, 90 percentile or maybe 98 percentile, whatever their expectation is. Um, and I think I look at all of these things, like there's been a saying from Albert Einstein saying, I don't know if you heard about it, like they call it, he calls it as insanity. Like, you do over things, doing over the same thing again and again until you expect, the right results, or you because you expect different results. So you would probably go over the same thing and again. So that's the definition of insanity. Um, but anyway, so that's just an example on how that deals with. So these are the machine learning approaches, and I think you might have went through some of these techniques in the previous sessions you had, but I think this is just to give an understanding on, what kind of modeling technique, if I would have to probably create a ML model, what would be those techniques that would fall into, right? So these are three different buckets I would put into: supervised learning, unsupervised, reinforcement learning. So think of a supervised learning. Okay, just to make sure, can you still hear me or no?
Yes, perfectly
Yes,
fine.
sir.
Okay, thank you. Yeah, so think of a supervised learning as like something like, you have some kind of a data, and then you label the data. So such a way, like, let's say, you got couple of emails throughout the day, right? And a lot of different people are sending emails. Maybe it could be a Gmail account as well, right? So your Gmail account, if you look at, it got a category of, like, it can able to put the data into the spam emails. It can categorize the data based off, like, you create a specific folder, and then you try to do a filter, right? And you categorize the data. So that's one of things where you call as supervised learning. So that means the data is identified based on the labels. Okay, so that's where you call a supervised learning. And some of these things, the supervised learnings can be an example of, like, you apply um, some kind of examples would be the house predictions, okay? Some which involves a linear regression algorithm, or maybe it could be a decision tree. So all of those things would fall under supervised learning. And then you got an unsupervised learning, right? So you don't expect much to be trained by the model, but rather, you don't have labels in this case, but rather it's basically, it's a semi-supervised kind of. So that's about the unsupervised. And the last one is the reinforcement learning. And I think if you have time, I think I would say, there is a nice documentary. I'll try to send it out, maybe if you're not watched it. There's a nice documentary out there for Google DeepMind. And I think I was looking at that. So that uses some kind of a reinforcement learning. So the Google has developed an AlphaGo. I don't know how many of you heard about AlphaGo. It's a pretty nice documentary, I would say. So there's a board game. I think it's more popular in China and parts of Asia, where what they wanted to do is through the reinforcement learning. It's basically just like, it's a chess game, right? So you put a superhuman uh, playing with one of the top professionals in the game, and then you try to see, whether the robot or maybe the bot can able to outperform the person who is the champion in that particular game. So the Google has done an AlphaGo. They call it an AlphaGo. Um, so Go is actually a game. It's a board game, and I think they brought a couple of different professionals from all across the world, and then they kind of, made these professionals. We call this a professionals in this game with this reinforcement learning technique, a bot that they've actually created. And I think they were surprised that, the AI system, whatever that they developed, has outperformed significantly, that, it has won like so many number of times. And I think I've seen that, if you look at the documentary, I think you would know what I'm talking about. But I think that's more of a reinforcement learning. So basically, you try to, depict the various scenarios. You train the model, right? And then you basically make sure that, it outperforms the what your expectations are. So it's primarily more on a deep neural network with advanced search algorithms. So I think that's an interesting thing to watch whenever you get a chance. So I think we got maybe a few more slides, I think here. Yeah, so these are some of the ML algorithms. I'm not going to go in detail on this, all the ML algorithms, but I think one of the closest thing that we would see is a linear regression algorithm today. So these are just to make a note of some of the algorithms that we have. And these are used for various different purposes, depending upon the use cases that you have. And I think if I have to probably, pick up, when would I choose one, the other, when would I choose the other, if given a scenario, right? So I would classify, the logistic regression whenever you pick up a logistic regression for the classification type problems, like whenever you have a spam or not spam, like email content, some kind of stuff, you do the logical regression. Decision trees again, you have some kind of a demographic information, right? And then you want to basically predict some kind of a customer behavior, right? So you want to predict a customer behavior living in a particular area. So you would pick up a decision tree in that scenario. And of course, you got some kind of analyzing a transaction history based off fraudulent transactions that you have actually seen. So random forest would be one of those techniques that you would probably see, and the random forest. So I think the complexity keeps increasing as you go up in the chain in terms of these different algorithms. The complexity increases. It involves a lot of different linear algebra, statistics, and all that, right? And I think you would have to probably know all of those techniques. But I think luckily we have some libraries which can able to manipulate some of this stuff, and then able to create these algorithms for you. You would definitely need some kind of a concepts on the linear algebra and statistics. I don't expect everybody to be a statistician, but I think you would have to probably know some of the concepts on these algorithms. So I think last three things, the face recognition, sorry, which has been a quite popular one, right? So the support vector machines is one of those techniques where it can help to detect some of the face reading capability in terms of the humans. So maybe I think I would say humans for now. I don't know about non-humans though. Might be possible, but I think this is some of the technique that's employed more in that area. The K nearest neighbor is also quite popular. It's basically determine some of the products. Let's say you got some products and you want to identify some of the user-based preferences. So let's say you have a couple of people, right? And in a particular area, you want to basically predict their purchase capacity, like what kind of products that they're actually buying. And then if you look at the Amazon, right, the e-commerce Amazon, Amazon basically definitely has a lot of algorithms run behind. So depending upon the customer's interest, right, um, the purchase options are given. As soon as you buy one stuff, it recommends you another product that they think they might be matching nearest. So those are some of the things that you can probably build around some of the products with this algorithm. So the last but not the least, the neural networks, right? So all of this would be an image classification. So identifying the objects within an image, okay? And basically this more of like, detecting animals, vehicles, objects on the road, and everyday items in terms of like the pictures and other stuff. So, and I think some of these CNNs, which we talk at, which we call like the convolutional neural network. It's a hard, it's a tongue twister, I would say. Convolutional neural network, CNNs. It's a better easy to say. CNNs would be one of those techniques that which would fall under that effective for this task. So I think we got just one more slide, and I think we can go right into the demo and how we can probably look at some of the one of the technique which we talked about. Then we talked about the linear regression model already. So which is basically like a basic linear regression model to start off. And then I think you would go up in the chain depending upon your complexity and the amount of data that you have. It all depends on that. Excuse me. So the linear regression model is something, and so I think one key thing to look at is there is something called a dependent variable and an independent variable. The dependent variable is a target, like means so let's say I think this is one of the example I have. Let's say I have different types of cars, right? And then the cars have a behavior where, I have a different cars of different make and model. And then I think I wanted to measure how exactly my car mileage is, depending upon some set of the attributes. So mileage would be that target variable against which I wanted to know how much would be the mileage given by a particular car. And the independent variables are considered as features where you basically look at all other data surrounding that the cars. Like maybe it could be like a horsepower, right? Maybe it could be amount of miles it's been driven or kilometers it's been driven. So those kind of independent other columns, other data elements that you talk about, they would come in independent variables, which are the features. So I think that's one thing to remember as you look at create a machine learning model. So I think the last slide I got is the tools and libraries. So I think one way that you could actually do is the Google Colab. Google Colab is pretty straightforward. You could definitely just start a notebook, create a notebook, and then you could just run an ML model. You could start off with an ML model by importing some libraries. With the Python, of course, and with the pandas is one of those other libraries, and the NumPy. And then you also use we talked about EDA, which is the visualization, like how do you want to look at the data, right? Like the histogram, the bar plot, the scatter plot, and all those plots. So you could use a scikit-learn. That's one of the package or a technique, which basically, it can provide dozens of built-in machine learning algorithms and models. So I think that's one of them. So it's scikit-learn is an open source machine learning. Give me one second. I don't know, something. I'm having difficulty here. Give me one second. So something popped up here, which I cannot. Okay, sorry. Yeah, so we're talking about the scikit-learn. So it's an open source machine learning library that supports both the supervised and unsupervised learning. It basically provides various tools for model fitting and for your data pre-processing needs, kind of like model selection, model evaluation, and other stuff that it can actually provide. Is anybody aware of, or maybe have you done like much of the Jupyter notebooks, or maybe Google Colab, or any of these open source library, the scikit-learn? Okay, perfect. And I think, yeah, the last one is the matplotlib. That's also one of the libraries to use. So I think with this, I conclude the slides. I don't have any more slides, so I would probably go out of this and confirm if you could able to, give me one second. Let me do a few things here. Okay, I hope you could able to see the Google Colab notebook. Can you?
Yes, sir. It's visible.
Okay, so I don't know the mix of audience in terms of whether you already use the scikit-learn package, and I think this is where I would start. The Google Colab is where I would start, right? And then as you go, you depending upon the complexity, it's all about like, how much of problem you have depending upon the data, you would do a further employ different algorithms that we have seen, like those algorithms, whatever that we talked about, random forest decision trees and all that. Excuse me. So I think that's a lot of algorithms, but I think the basic one is the linear regression. So if I would have to probably talk to, somebody who doesn't know how to set up this, the Google Colab, if you try to, do the Google Colab, it's a straightforward. Basically you have your Google Colab compute, and then you have your, your RAM, your runtime environment is provided by the Google. Jupyter Notebooks on the other side, you all can also install Jupyter Notebooks. I've not seen an online version, but maybe they do have, but I think I'm more familiar on the Google Colab. So it's pretty easy. You could just get that going within a fraction of seconds. So I think I have an example here. I think maybe we could go through that, and I got a couple of examples. So depending upon the time that we got, maybe like another 20-25 minutes, I don't know. So we could probably go some of the examples here, and I can probably share some of the examples. I can put it on a GitHub somewhere, and then I think you could probably go look at those examples. So to start off here, I wish I had a explanation of the problem here. So what you're trying to look at is we're trying to create a linear model that explains basically the relationship of a car's mileage, which has some of the attributes. Okay, so maybe we could look at the CSV file here first to look at the data. Give me one second. So it's a pretty simple data set what I got. Maybe I might have got like maybe about 400 entries. Might not be the same as you deal with large amounts of data related to like, the hospital management or maybe insurance or maybe financial data sets, which might be more complicated. But I think in the simple example, what we are going to look at is you got a car, different cars and their type of the cars, the cylinders that the car has. And then you got the horsepower, the weight of the car, acceleration, etc., etc. So we will go through those steps what we talked about, and I think I listed down some of those steps here in the commented here on how it can be done. So the very first thing that you would do is you would import these libraries, right? And then you would run in the Colab. And I think once when it is, give me one second, let me close this out. Okay, so this is already connected. And then I think you will go through, either you could run these. I think I don't know how many are familiar with the Colab, but if you're not familiar, it's basically quick and easy. So you could basically add any cell. So the moment you add any code cell, you could just click on this code cell. And there is also another way that where you could actually add a cell from here as well. Insert code cell and text cell. Anytime you wanted to write a description, maybe some notes, you would just click on the text cell. You could type in something. Your observations can go into the text cell, and then your actual runtime can be in the code, which is a code cell. You can keep adding as many as you could. This is one way of doing it. Another way of doing it is through the Python PyCharm. PyCharm is one of the community edition where you get it for free. You could also do some of the stuff there, but I think this has been more easy than having your own ID and doing in that. But I think this is one of those. So I have pretty much the needed libraries here. And I think if you'd have to probably learn, go through the glossary of the scikit-learn, maybe I can just put this in the chat. Give me one second. So as you probably go look at, I think it's pretty extensive. So you have different algorithms here, like you got classification, regression, clustering, and then I think you got a lot of stuff here. So you could probably go look at this library and get familiarized with it, I would say, depending upon the kind of the problem and what the data set that you got. But I think, yeah, so that's one thing. And then a matplotlib is another library. You can probably, just go and do it. I mean, just go to the documentation in terms of like how you can probably visualize using the matplotlib. It's all basically, you have the data and then you're trying to map the data against X and Y columns. And then, how you can probably beautify the data. So that means you have a presentation that you would have to show some kind of a business insights, like which we just talked about, right? You have some kind of insights that you want to show. So you would employ this matplotlib library, and then you can probably draw, different diagrams in terms of, understanding the various relationships of the data. So I think that's something that you could probably do. So that's one other library. Seaborn is also another library. Let's go to the Seaborn. Yeah, statistical data visualization. And I think you could also do something. So those are like two different libraries again for visualization. So depending upon what you need, you could probably use it. It's not like, there isn't any comparison, but I think these are two different libraries against, how you wanted to picturize graphically in your data. And I think that's a lot. I think you got a lot of documentation here on the Seaborn library here. I think if you look at, using a Seaborn, you're trying to plot a spending USD, life expectancy, and maybe a color. So this is how you can probably use the plot here. So likewise, I think you got various stuff here. You could probably draw, the histograms here using the Seaborn. So you basically just call the function of the library, and you can depict your data based on yeah, what about the picture you want, like in terms of making it more like, visualization. And I think all of this would be more recommended for business insights, right? So that would basically be, one of an ML engineer would have to probably go through this and do the exploratory data analysis. So these are some of the basic stuff that you would probably know, right? And I think you would get more insights into this. But anyway, I think we talked about a lot on those libraries. So here what I would do is, so the anytime you create, you can just create, file new notebook in the drive, and it gets attached to your Google Drive. Excuse me. So what you do is you basically just upload the CSV file, the data set, into the drive, and then you can basically just, select the copy path of the file, and then you basically read the file, like you read CSV through the pandas. So use pandas here to read the data. So I think here here I'm trying to basically just load the data, and then I'm saying shape. So let me just run this. The shape basically gives you the number of rows and the number of columns present in the data set. So here you got 398 rows and you got 9 columns of the data set related to the cars. And then I think this is just some of the basic stuff, like, you're mounting the drive. So that way, you're available, the drive is available for the Google Colab to access your files. So that's something you're mounting the data. So here, if you have to probably go, so I listed down some of the comments here. So some of the things that we are looking at, the miles per gallon, the number of cylinders, the displacement, which is nothing but the number of, yeah, I think the displacement is, I don't know, to probably see what exactly the displacement would be. I think it probably refers to the total volume of all the cylinders in an engine. Yeah. So in the context of the car engines, yeah, perfect. Yeah. So I think engine capacity. So horsepower, vehicle weight, and all that, etc., etc. So I think, so if I do a head on the C data here, right? And I think there's one more thing that you could probably do is it also gives you an API definition of the. So if I go back into the shape, right? You do have a documentation that takes you, what the parameters are, what it is trying to take, the function, what parameters the function is taking for the data frame. So those are some of the things that you could go look at. So I think here, what we are going to do here is like, as we talked about, first is cleaning up the data, right? So what I'm trying to do here is I'm trying to do a head, which basically gives me a 5 rows from the data set. And then I look at the data, and then I don't think that maybe, my data is 100% accurate. I might have some kind of a data elements where, the data could be null, or maybe the data could missing as well, right? So I start with the exploratory analysis here, right? So what I'm trying to do here is I have a car name here, right? And I don't need a car name as part of my analysis here, so I'm dropping the car name here. Access equal to 1 basically allows, you're dropping the column for the access equal to 1. So what I'm also doing here is origination, the origin. So let's say, like, I think maybe I've already done I think earlier I ran this. So I have like, yeah, no, I think maybe not. So what I'm trying to do is I'm trying to convert this categorical values here with the numbers here, and I think I would tell you why we are doing that in a bit. So we're replacing the categorical var with actual values, which is like, replace America with 1, Europe 2, and then Asia 3, and then I'm trying to do a head on that again. So further, what I'm trying to do is I wanted to basically figure out, if the origin of this is using some kind of an equation, right? I'm trying to substitute like 1 for America, 2 for Europe, 3 for Asia, implying, what kind of assumption that I could probably make out of this data, right? So something like, if the equivalent of this, like, let's say if this is America, like a Boolean function, I know that it is, the other, the European and Asian are basically 0, right? So I can basically infer modifying the data. So these are some of the things that I could, I'm trying to modify the data over here. And I think dealing with the missing values. So what I'm trying to do is one important function here is data.describe, the data frame.describe here. So what does it actually give me is it basically gives me a mean, standard deviation, a max, and count of all the different values here. Basically, the describe function gives you a statistical summary of the data. And then you got another one called D types, where, it basically gives you the data types of the data set what you have. And I think these are some of the data set. I think the most important one is to look at the objects as well. Sometimes you might have to convert some of the objects to integer values, especially when we cannot able to make out data analysis. So the key thing is you expect the values to be more numeric to perform the data analysis. So in this example, what I'm trying to do here is I'm trying to figure out if the horsepower, I think here the problem though is the horsepower has some kind of an invalid values here, right? So what I'm trying to do here is I'm trying to replace this horsepower column with some kind of not, a null values, right? So I'm trying to replace, because I think if I have a horsepower value like this, I cannot able to, basically make it, I cannot able to make my analysis perfect. So that's what we are trying to do. So I'm using an ease digit function here, where, I'm taking the horsepower and then trying to figure out if it is a digit or not. And I think I'm running a logic here which says, if it is a digit and if it is false, I'm trying to compare if this is false or not. So yeah, so I think so that's how I think, and then I'm replacing this with the np.nan, replace the missing values. And there is also another ways where you could also replace missing values with a median or mean as well. That's another technique that you could also do. And it all depends. So I think you're trying to basically clean up all the data. And I think you would make a call here, like whether you need all the data elements that you need. And let's say some of the data is not meaningful, and then, there are more null values, and you do definitely the imputation or the substitutions of the data. And at times when you think like maybe a particular column might not be important, you'll drop the column. So that's one of those techniques that you could do. So I think I listed down here, yeah, there are various ways to handle missing values, drop the rows, replace missing values with, excuse me, with the median values. Yeah, so I think here in this example, 398 rows, 6 have NaN in the HP column, right? And then we could drop those 6 rows, which might not be a good idea under all situations. So let's say if the data set is small, that's fine. You could able to drop some of the rows, but let's say you got some of the data, significant chunk of data, right? Where you cannot drop the columns in that case, right? And then you'd have to substitute with some kind of a replacement technique here. So I think here it basically gives you a median here, right? Just some functions that we are running. So what you're trying to do also further down here is I think we already talked about replacing the missing values with a median value here. And we are using a lambda function here where you're filling up some of those rows with a median for that particular row. So I think that's one of the techniques that you could use. So you're basically converting the HP column from object to string type here when they're trying to define if. So you're basically replacing with a median. And then here you're checking if the type is a float or not. So I think we could probably run this. I think you would have to probably, load the data set again. Give me 1 second. It gets disconnected. I think, 1 second. It's mounting the drive and then it can able to. Okay. Yeah, I got the file and then I got cdata.head. I'm dropping the car name here. And basically this is another one where you're trying to create a dummy variables, which is called as a dummy way of doing it, dummy variables. And then dealing with the missing values. I think we'll probably look at the definition of how do we do the visualization. That would make more sense. So horsepower is still the object, and then you got some of these origin here, which is a Boolean value for my prediction. Yeah, so what I'm trying to do here is I'm trying to determine if the origin is true, right? Either if it is the origin for that particular row, either it can have only one value, right? Whether it can be Asia or whether it can be Europe or maybe it could be in America, right? So it can have any of these values. One of them can be Boolean, the other two remaining columns can be the row of that value can be false. So at that time, at some point, you can probably, you can think of like you could drop a column if it is not necessary because you don't need all the three. It is implied that when one of them is true, the other one is false. So I got a median here. So I'm running the other stuff here. And maybe let's me just do a C data. No, then it is a B.Tech, sorry. Yeah, so I think we are seeing the horsepower is now converted to float 64. But anyway, I think that's what you would probably do some kind of imputation in the beginning. And then I think you would probably have like, different kind of a pair plot or maybe, scatter plots. Sometimes these visualization take time. And I think especially when you're also running the model, I think we didn't get to the model yet. When you're running the model, sometimes the models can also take some time. So I think here, so what we're trying to look at here is you're trying to do a bivariate analysis here. So trying to determine like, various dimensions. You're basically measuring how does the horsepower look like, right? Given those set of different rows. And then how are the different cylinders? How is the miles per gallon? And I think I have a summary here. So what does it all do, right? So the observation from this is, since it is a linear regression, what we are trying to look at is as the miles per gallon, right? As the miles per gallon increases, the weight of the car decreases, right? So if you have a heavy weight of the car, right? I think this is just one of the examples, and then you could infer some other stuff as well. As acceleration increases, right? You get the the mileage will be low, the miles per gallon is low. So those kind of inferences that you could actually make out by this various analysis. And I think you could probably plot and then determine, okay, we think this could be the right what do you call the transformation that you want to do, right? And you try to identify the linear relationship. So basically you try to identify a pattern, and then you probably go into the building of the model depending upon the pattern. So that is one of those things that you would do in the EDA. So after you do the EDA, what you actually do is you go into the creation of the model, and then I think one of the things that we always talk is like there is a 70-30 ratio, right? So you basically split your data set into two portions. One is a training data set, another one is a testing data set. So what you're trying to look at here, you can just forget about the origin Europe. So what we try to do here is you split the data here, like X train, X test, Y train, Y test. So this is how you do. And then you call a train test split method, and then you pass an X and Y, and you pass a text size and the random state. You could probably look in the documentation what these values are. But I think essentially you're trying to basically call a train test split method, and then you divide the data based off a 70-30. So what you're trying to look at here is you basically create a model, right? And you basically, after you run the model creation, you basically analyze if the model is performing based off your expectation or not, right? So in this case, it's a pretty straightforward example. So in this case, what you're trying to do is you're doing a linear regression, and then you're trying to fit by calling a fit method on the linear regression, and then you pass an X train and Y train. And then I think once when you do that, give me 1 second. I got to run here. Okay, so I have the linear regression model being created, and then what I'm trying to do here is I'm trying to do a coefficient here. So basically the coefficient would give me some kind of a matrix here, like kind of like, I would get the impact of each of these predictors, like how exactly the horsepower, displacement, weight, and the target variable. Anytime you have a negative coefficient, that basically signifies that any of the parameters when they increase, right? The associated features, they basically decrease. Like in this example, as the weight increases, you have the mileage per gallon, right? decreases. So they are like inversely proportional. So these are like the negative coefficients. So the sum of those things here you can able to depict out of that. But I think the last thing I would probably, go towards the end of this notebook is, so once when you do all this and then you create a linear regression model, you basically call a score method, right? And then you pass basically your X train and Y train. And then you get basically an accuracy of, 0.81, which is 81% of the times, right? Which is 81.41% of the variance in the training data. And then this training data is explained by actually the model. So it basically suggests a model is a good fit of the training data. But again, this is a test set. And of the test set, you got, 0.84, 33 something. So which is like, you got a testing data of 84.33% of the variance in the model. So it basically it basically says that you would measure like whether your test data is performant or not based of the business justifications that you want to figure out. So I think that basically concludes like how you can able to infer based of a simple linear regression model here. And I think as you go into the more of a complex algorithms, you would employ other techniques as part of that. So the R square, which we are talking about here, right? The simple R square, it basically allows you to determine, how you're training and testing data based on of a relative interpretation. And I think that's about, so it's basically a metric for evaluating your performance of a regression model. And I think we talked about like, yeah, this does basically based off an independent variable and dependent variable. And all of that would be the R square method of doing it. So I think that's part of the linear regression model that you could employ. So basically a slightly higher R square on the test data usually suggests that the model maintains, the some kind of a good predictions. And I think it basically provides a confidence in terms of the reliability and the robustness. So I think that's way to look at the generalization of that. And I don't think we can able to go through some other examples, but I think considering the time that we have, and I think that's how you probably go and create a model. And then you could definitely infer the results based off the model efficiency, based off your accuracy. The what it outcome is basically you could determine whether it how accurate is a model depending upon the percentage of the accuracy that is being determined. And we don't expect, most of the times it depends upon the test data. Whether sometimes the models can be like 94 percentile, 90 percentile, 91% of the accuracy, but sometimes it might not be easy to achieve that kind of accuracy. So there are a lot of factors involved as part of that. But I think I would stop here and I think conclude. And I think I can probably send out some of the documentation and then maybe some of the advanced notebooks for you to take a look at that, and then I think you could probably do some hands-on on these machine learning models. So any questions? I would stop here and I think open up to see if you have any questions.
Any questions from the participant side?
Good morning, sir. So can you please share your GitHub link?
Sure, yeah, I can. I don't have this notebooks right now, but I think I have like bunch of different data sets, but I can able to send that out probably by tomorrow.
Sure, sir. Thank you.
Sir, I have a question that's not exactly related to this.
Sure.
A lot of students, they when they are in the final year, they're looking for what kind of certification they do. So since you are on the AWS platform, so is solutions architect is a good certification to do in terms of getting placement or something?
Yeah, so I would say, yeah, leaving aside machine learning, so everything today we have is definitely on the cloud. So it's good to have the certification for the AWS cloud. And I think you could start with a practitioner and then you could go up to the solution architect as well. I think there's also a professional one as well. It all depends. I think I would say certification might not land a person like a job, but I think it at least proves the credibility of that, the person has done the certification and then, he has some kind of a understanding on the cloud services. I think it's good to have. I mean, but I wouldn't say like whether it will land a job or not, if that was your question. I would say, yeah, the certification is good to have it, especially when you don't have a real-time experience on the cloud. I think you could probably do more certifications and then add to your profile.
Thanks.
Does that answer?
Yeah, absolutely.
Okay, any more questions?
Any more questions? I think no more questions, sir.
Okay. All right then. Thanks for your time and wish you a great day. And I think you could probably connect with me. I'll share my email ID. You can connect with me if you want to on LinkedIn. And I think you could send out any questions you have. Okay. Thanks for your time. Have a good day.
Yeah, sure,
Bye.
sir. Thank you, sir, for your informative session. Thank you, sir, for your informative session. Your insights have been very valuable, and we appreciate your time and effort for sharing this expertise with us.
Yeah. Thank you, Shilpa, for your time. Thanks for coordinating this.
Just for a minute, sir, I just request all the participants to switch on the camera for a group photograph. Sir, just stay for a while, please.
Sure. Do you think you could able to
I
capture
request all the participants.
Sorry.
I request all the participants to switch on the camera for a group photograph. Okay, it's done. Thank you, sir.
Yeah, thank you. Bye.
Thank you, all of you. We will have a next session at 2 p.m.